So today is officially the start of our geometry unit, and one of the basic building blocks of geometry is angles. Now we will not be using the book today, so you don't need to bring it to class next time. And if you would like to print out a copy of this outline, I will have that posted online on Canvas with the video. You should have seen the link when you clicked on the video on Canvas. So our goal today is to be able to identify all the various angle relationships that are possible and set up equations to solve for angles. So some of our basic angles are acute angles, obtuse angles, and straight angles. And hopefully these are terms you recognize and have heard before in previous math classes. So when we're talking about acute angles, we're talking about angles that are from 0 degrees to 90 degrees. They are less than 90 degrees. You think cute, small things are cute, so small angles are acute. If we want to think obtuse angles are big angles, so angles between 90 degrees and 180 degrees. And then we have a straight angle, which is just a straight line, and straight angles are 180 degrees. So then I almost forgot a right angle. A right angle is exactly 90 degrees. And we use that little box in the corner to show this is 90 degrees. That's another way to write 90 degrees without actually writing the number 90. So those are some of our basic angles we're going to be working with quite often. We need to know those names. Half of geometry is just knowing what things are called. So we have a couple of different ways that we can interact with our angles. So all angles are formed by lines intersecting each other. So if we have two lines intersecting each other completely, then we have vertical angles. So when we talk about vertical angles, we're talking about the angles across from each other. So if I label this top angle, angle 1, and I label this bottom angle, angle 2, then the measure of angle 1 is congruent to the measure of angle 2. That's a very fancy way of saying those are the same angle. So measure of angle 1 is equal to the measure of angle 2, or congruent. Usually in geometry when we're saying shapes are equal to each other, we use the term congruent, which is that equal sign with the squiggly line on top. If we look at the other angles as well, the measure of angle 3 is congruent to the measure of angle 4. So the angles across from each other equal each other. Our next angle relationship that is possible is when we have a line that's either this really could intersect all the way, or we just maybe have a ray sticking out, and that is supplementary angles. So I'm going to label these a little bit differently this time. I'm going to say A, B, C, and then over here we're going to label that D. So supplementary angles, if they're on a straight line, that means they're the same thing as a straight angle. These two angles together should add up to be 180 degrees. So supplementary angles, if I said angle A, B, D, so when we label an angle, we start at the one point, travel along until we hit the second point, which in this case is B, travel along until we hit the third point, that's D. So we have angle ABD. So if we add the measure of that angle to the measure of the other angle on that line, so let's say we start at C, travel to B, and also then go to D. And if we add the measure of angle CBD, those two together, since they're on a straight line, they should have the same angle measure as that entire line, so those two together equal 180 degrees. So we have two more angle relationships that we're going to be learning. The next one is complementary. So complementary angles, we're looking at these two angles on the right. This time I'm just going to label them angle 1 and angle 2. There's multiple ways to label these angles. Now, we can't assume this is 90 degrees right off. You can't assume things in geometry, even if the picture looks like it's 90 degrees. But if I put this little symbol on the left here, if we know that left side is 90 degrees and it's on a straight line, we know the right side is 90 degrees, so then we would know the measure of angle 1 plus the measure of angle 2 is 90 degrees. So if we ever have the term supplementary, we know the two angles are going to add to 180. If we use the term complementary, we know the two angles are going to add to 90. The last situation doesn't really have a name, so that's why I don't label it with a name. But if we have three angles here, and they travel around in an entire circle, if we start here, go through angle 3, then through angle 2, then back to angle 1, then we complete an entire circle. And if we have an entire circle, we know that those all together add to be 360 degrees. It doesn't have its own specific geometry name that I know of. Who knows? It's possible there is one and I just don't know it. So those are going to be the angle relationships that we are focusing on. So let's do some examples to show what kinds of things we're going to be doing with those angle relationships. So example 1, identify the angle relationship. This one's just asking you to put a name to it. So for identifying the angle relationship, we have some options. We have vertical angles, we have complementary angles, we have supplementary angles. We have the last one, which didn't have a name, but that won't appear on this identify one, so you don't have to worry about that. But if we're going to identify the angle relationship, we look for some of the key features. First, we look for where are the angles located. There's angle B, there's angle A. So even though there's more to the picture, we really only care about the part of the picture that has the angles. So we only care about that part of the picture that I highlighted in blue. So we're trying to decide, are these vertical angles, complementary, or supplementary angles? So we think through all the definitions. Vertical angles are across from each other. Well, these angles are right next to each other, and that actually has its own name. We call angles right next to each other adjacent angles. Adjacent meaning next to. Okay, so those are next to each other, so they're definitely not vertical. So then we think about complementary and supplementary. Well, we know complementary adds up to 90, supplementary adds up to 180. So if we had used the entire line to make the angles, we would have supplementary. But since we only used half of the line, we have complementary angles. So the identifying, pretty easy. We're just trying to put a name to the picture. But we can also find the measure of an angle if we know the situation. So looking at example 2, the reason we need to be able to identify, so we need to identify what situation do we have so we know how much these angles should add up to be or if they're supposed to equal each other. So if we're finding the measure of angle B, we're looking for this angle here. Again, there's more to this picture than we need. I only need the angle I'm looking for and the angle that is given. I don't need the rest, so we only need this blue area. So looking just at the blue piece, we don't need this anymore. We can see, well, I'm on a straight line. So we think back to our angle relationships again. So we know if we have a straight line that we have supplementary angles. And we know that these pieces should add up to 180 degrees. So I know angle B plus that 77 degrees should add up to be 180 degrees. Well, that's a pretty basic equation that we can solve. In fact, you probably thought of the process of what you should do in your head before we even wrote out an equation. If we're going to get B alone, we just take away 77 degrees. But what we do to one side of an equation, we must write on the other side. So if we just take away 77 from 180, that will give us the measure of angle B. So if we do that subtraction, we get 103 degrees. So that's the most basic version. What if instead of just numbers there, we start with some equations instead, some expressions? Let's say we want to find the value of x here. Again, there's more lines than we need. I'm only looking at this angle 36 degrees they've labeled and this 2x that they've labeled. So the lines making those angles are these two lines in the center. I don't need the top and the bottom line. They don't give me any information. So again, we think back to our relationships. We know that these are vertical angles. And we know vertical angles equal each other. In fact, we use the word congruent. But now that we have equations there, we can start using our equal sign and get some of our algebra involved. So we know 2x should equal 36. Once again, once we've set up the equation, now it's just up to us to remember how to solve it. So we think to ourselves, okay, we have 2 by the x. Our ultimate goal, get x alone. I want to isolate that variable. So we've got to get rid of the 2, but we have to use our opposites to do that. So if we have 2 times x, the times sign isn't written there, it's another invisible part of math. So we have to do the opposite and divide. So we divide both sides by 2. So we get x equals 18. Now I specifically did not write the degrees symbol there. 18 is not in degrees. That's what x equals, but that's not what the angle equals. If I just want to find x, I'm done. If I want to know the actual measure of that angle, I'd have to go and take the answer I just got and replace it in the x spot to get the actual angle measure. So we get that that angle is 36 degrees, which makes sense because they're vertical angles. So we know the two angles across from each other should equal each other. So we're going to do one last example. Our last example, find the value of x. Now this is the situation where we didn't have a name for it. But that's okay, we still know what all of this should add up to be. And this time, every single line is used. They didn't give us extra lines that don't give us any information. All of our angles are formed by all of the lines that are actually there. So we said all of this adds up to a certain amount. And we said that amount should be 360 degrees. So we said 212 plus, and then we pick another angle, 60. So we've used 212, you've used 60, plus 2x plus 4 should all equal a certain amount. This should equal 360. And this is the process we'd use if we had supplementary or complementary, except this 360 can change if we have supplementary or complementary. If it's supplementary, we'd add up what we have and set it equal to 180. If it's complementary, we'd add what we have, set it equal to 90. Now that we have this set up, we need to just solve this equation. So we're going to go through and find any like terms we need. So when we find our like terms, we focus on one side at a time. We don't find like terms on opposite sides. So on the left side, I'm going to start with 212. A like term to 212 on the left side is 60. 2x has an x, so it's not a like term, but 4 is also a like term. Now 360 is on the other side. It doesn't have any numbers on the right side with it, so 360 is all on its own. And 2x is the only variable in the entire equation, so that's on its own. So we combine our like terms. 212 plus 60 plus 4 is 276. Doing the math in my head right now, so hopefully I'm correct. And then we just bring down those loners so that it didn't have anything to combine with. And now we're just to a basic equation. Again, we're going to do opposite operations. We need to get rid of 276, so I minus 276 from both sides. Bring down the 2x. 360 minus 276 is 84. And then I need to get rid of the 2, so my last step is to divide both sides by 2. So if we divide 84 by 2, we get 42. Again, since that's x, I would not label that with degrees. If we wanted to actually find the degree measure, we'd go back to our expression that had an x, plug it in, so that we could get the actual angle measure. So we have 2x plus 4. I'm going to replace x with 42. 2 times 42 is 84, plus 4 is 88 degrees. So the actual angle measure is 88 degrees, which again makes sense because if we added them all together, 212 plus 80 plus 60, 88, the wrong thing up there, plus 60 is 10, 6, 360 degrees. That's what it's supposed to equal when we add all the things in this situation when it goes around in an entire circle. So enjoy your weekend, and I will see you guys on Monday.